Now, what about sig figs here? Well, what we're going to do is H plus and then A minus. That's a kind of a sneaky way of writing these. So the Ka expression would be the H plus concentration, okay, very small, such that 0.05 minus X is going to be basically 0.05. First of all, when you get a solution question like this, you have to identify strong or weak acid. Hydrochloric is one of the 7 strongs. What that means is it completely dissociates. And so go ahead and write that dissociation reaction. And then the concentration we're given is 0.10 molar. So what is the pH? Well, all of that HCl is going to dissociate, so that concentration is going to also be 0.1 molar. And then, of course, the chloride will also be 0.1 molar as well. And then how do we get the pH? Well, here's our formula. So the pH is going to be equal to the negative log of our hydrogen ion concentration, which is 0.10 molar, and that's going to be 1. Now, what about sig figs here? Well, what we're going to do is we're going to use the sig figs of the concentration. There are 2 there. We're going to have 2 sig figs after the decimal. And so our pH in this case will be not just 1, but 1.00. So that's how you handle sig figs in pH. Well, let's do a weak acid. Now, if you were to look at this formula here, would you not guess that's an acid? Because sitting right there on the front is your H plus that's going to come off. And so we're going to write the dissociation reaction. Now, this one is an equilibrium situation, right? So we're going to have some of the acid together, some of it coming apart. And we've got the pH here. The pH is 2.38. So that's going to give us a clue as to what our hydrogen ion concentration. So our H plus concentration is 10 raised to the negative 2.38, and you're going to use the little caret button in your calculator, and let's get that value. That would be 4.2 times 10 to the negative 3rd molar. So that's our H plus concentration. So that is that, and it's also actually the back end of the acid, the rest of the acid as well. And so let's write the Ka expression. Also, you can, this is a general format. This is H plus and then A minus. That's a kind of a sneaky way of writing these. So the Ka expression would be the H plus concentration times the A minus. It just means the rest of the acid, and then divided by the acid concentration. All right, let's go ahead and plug in our values. So both the H plus and the A minus are the same value. That's 4.2 10 to the minus 3rd molar, and we've got 2 of those, so we can square that, right? So the same number times itself, and then we're going to divide by the acid concentration. Well, that's 0.1 molar minus the amount of the acid that comes off. Okay, and that may or may not be significant. Run the numbers. We're going to go 1.2 10 to the minus 4th is our Ka. Okay, and Ka, that is just the acid dissociation constant. These values are found in tables in your textbook. You can look them up online. And that is how you get a Ka. Now, let's do one more problem. This time, let's say we know the Ka and we want to find the pH of a particular solution. So what we're going to do here is we have 0.05 molar, and then some amount of that is going to dissociate, and I'm going to assign that a variable x. That's how much is going to come off. And so if x molar comes off, we'll have x molar of this and then x molar of the rest of the acid. So let's go ahead and write our Ka expression. So Ka is equal to the concentration of the acid, remember, and then the anion, what's left over, and then the acid itself. Okay, well, now I'm going to plug in my concentrations, right? I assigned x as the H plus, and then I've got x for the rest of the acid divided by 0.05 minus x. Okay, and I know that all of that is equal to the Ka, which I have given in this problem. And so I'll set that equal to the Ka, which is 1.8 10 to the minus fourth. Now, mathematically, this gets a little hairy, right? Because that x on the bottom there makes this warrant the quadratic equation. And generally, you can assume that this is very small, okay? Very small, such that 0.05 minus x is going to be basically 0.05. So if it's very small, we can assume that's negligible. That makes the math a whole lot easier. If we solve for x, x is going to be 3.010 to the minus third molar, okay? And that is really pretty close to small, okay, as far as taking that away from the 0.05. Makes our math a whole lot easier. So what was our x here? Well, that was our H plus concentration. And so the pH, which is what we're really after, pH is the negative log of that H plus. So the negative log of this value is going to be 2.52. Okay, so the pH of that weak acid is going to be 2.52. A little bit more complicated. You can use this X. This is what you are assuming, that X is the concentration of the hydrogen ion in this case. So that's a nifty little trick that will help you in some of these weak acid problems. I hope that helps.